Nice. Yeah, let's see. Victor, how are you? Gerardo, how are you? I like your background, Victor. Look at you.
Yeah, right here in the
Getting fancy with that
nice
Zoom.
view, right?
Are you using your cell phone?
Pardon me?
Are you using your cell phone?
No, it's an iPad.
It is. Oh, okay. So you have it in the portrait mode instead of landscape. Yes. That's
Oh,
right.
there you go. Much better.
Oh, okay. Whatever works better for you. Yeah.
I know iPad made the same need, so I was looking at see what.
I hope, yeah, this would be better for you because my next share screen will occupy the entire screen. So.
Oh, look at what I got me. Oh, here. I beam the whole conference to the TV, so the TV is pretty big.
Nice. Good for you.
I just log in here, but I
Yes.
see TV.
Nice. Okay, then we'll make it very large so that you can enjoy maximum view. So I have a question for you, Victor. So
Yes.
are you all loaded with MultiSIM 14.2?
Yes.
Okay. Okay. Because your first assignment will be tonight.
Beautiful.
Okay, just a few more people. So while we're waiting, let me go to the share screen for a moment. Okay, so on the share screen, let me do this for now. I've got to keep an eye out for other people coming on, but we go to our dashboard and we go to our class, and this is what you can download in week 3 so far. So in week 4, but this is something I didn't get a chance to talk to you about in week 3, and that had to do with the 555 timer multisim. So on this particular assignment here on the share screen, I hope you can see it, it shows week 3 multisim 555 timer wiring upload. So I'm going to click on this guy and it'll open up like so, and it'll have 2 files for us to download. So while we're waiting for other people, why don't, Gerardo, I see you on also, Gerardo, why don't you just go ahead, download the PDF and download this MS11. So this is a multi-sim version 11. It's an older file, but you can open it on yours. So, okay, we have Ivan Suarez is coming on. This is great. So for 51, we have Gerardo, and we have Ivan, and we have Victor Montano. Oh, cool. Outstanding. Welcome, Ivan. We're just getting started. So what I have you looking at is my share screen. And on the share screen, you should be able to see Canvas. So on Canvas, this is something we didn't get a chance to talk about last week because not everybody had everything loaded up. And there's Oscar. All right, cool. Turn on your camcorder, turn on your camera, and turn on your microphone. Oscar and Ivan, please. So Oscar's here. Yes. 1, 2, 3, 4. 1, 2, 3, 4. 5 people all together. This part is good. So connecting to audio, Gerardo, Ivan connecting to audio. This is good. So Gerardo, Ivan, and Oscar, you can turn off your microphone, turn on your microphones, please, so I can hear you, and turn on your cameras so I can see you. And so while you're working on that technology, you should be able to, hey, Oscar, how you been, pal?
Not well, actually.
Oh, you poor guy. Oh, no.
I was actually really sick.
Oh, no, not with the COVID-19, we hope.
No, I have
Other issues.
gut issues. Yeah.
Okay. Well, we missed you, so it won't be hard to catch up on a lot of this stuff. So I'll chat with you separately after we're done with the entire group, okay?
Alrighty.
All right. So let's see. Okay, Izar is coming on, so let me admit Izar. So Izar is coming on. That's great. Ivan, how are you?
Hey, doing good. How you doing?
Pretty fancy there with the little headphone microphone thing. Yeah,
Yeah, I just found it.
that's handy.
Mm-hmm.
Yeah, it's particularly nice if you're in a say a shared space.
Yeah.
With family and
yeah, they're like behind this wall.
They don't have to hear me talking so loud in the background. That's fine. Okay, so what we have here, gentlemen, is welcome to week 4. I know that the share screen shows MultiSIM week 3 555 timer, and what we couldn't do last week was this exercise because not everybody was able to have a elegant download of MultiSIM, and so over the weekend I put together another tutorial that I posted in YouTube on how to, I sent out a PowerPoint. So I sent out the PowerPoint on how to download the latest version of MultiSIM, and it is free if you follow the steps. It's in my PowerPoint, and it is free for 6 months, which is nice. And it's full strength. Actually, it's more current than the one I have. The one I have is still version 13.0, and you guys are getting 14.2. So I happen to have that on a separate computer, which I'll turn on in a moment just so that we can have some discussion about it. So let me go ahead and mark this. So Edwin is here. All right. So just a couple more people, not yet, but I'll keep an eye out for the, hi Edwin, how you doing? Microphone is, you can unmute your mic. Yeah, most of the time, unless you happen to have a lot of other family activities happening in the background where kids are running around or the dog is running around and there's just a lot of background noise, you guys can all just turn off your microphones so we can chat readily. And so if somebody asks a question, then everybody hears the question. And then when I respond, then everybody will understand what the response is for. So go ahead, turn off all your mics, unless there's some, jackhammer happening in the background or something. Okay.
For me, there will always be noise around because I'm still at work.
Oh, okay.
So I'll keep muted it back and forth.
That'll be fine. That'll be fine, Edwin. Yeah, if there's background noise, then yeah, by all means, just go ahead, put yourself on mute, and that way it'll keep the discussion as with as little distraction as possible. So on week 3, there's 2 files to download. One is the 555 timer schematic. So let me go to open up the schematic. Do you see that on my share screen now?
Yes.
Okay, I'm going to maximize this, and now you see it on the share screen, and I'm going to go bump, bump, bump. Okay, this is your 555 timer flasher circuit. Now, to understand how this guy works is to help you also understand next week's soldering project, not this week's soldering project. Next week's soldering project has to do with this particular schematic. So you will be building the 555 timer with very special LEDs. There will be surface mount LEDs as well as conventional LEDs on the circuit board. And so we need to talk about how this guy works, help you understand it in the schematic, and then help you understand how to build this, wire this in MultiSIM, and how to test this to make sure it's working properly, and then build it next week via soldering. So there's a lot of stuff that we need to get done in the next hour, hour and a half, okay? So let me explain to you what you have here. On this side, can you see my moving on the screen? Okay, so over
Yes.
here we have a standard 5-volt supply, and on the standard 5-volt supply, we're supplying on the positive side everything at the top. So this wire up here is all positive 5, and then on the bottom, everything on the bottom is all ground, and then there happens to be a ground. And this is, just to remind you, not earth ground, but this is a common reference point ground, meaning this is the lowest potential on our schematic, and is what takes us back to the negative side of the voltage source. What we got going here will be red LEDs and green LEDs. And so the 555 timer is a very special chip. It's an 8-pin chip, very popular chip. It's used for a variety of different circuits. You can build frequency generators, you can build waveform displays, you can do all kinds of, as the circuit says, timer circuits out of this. It's a very, very versatile microprocessor. The way it is wired right now, it is using a timing function between these resistors, R1 and R2 plus C1 as part of the timer circuit. And what we just touched upon just a little bit in 50 last semester was the RC time constant. Given a capacitor, given a resistor, there's a certain amount of time for the capacitor to charge, and there's a certain amount of time for the capacitor to discharge. Well, based on these characteristics of a capacitor with a resistor tied to this pin of the 555 timer, we can adjust the timing of how these LEDs over here flash from red to green, from green back to red, red back to green, green back to red. So you're looking at this and say, well, why are there 2 reds and why are there 2 greens? It turns out one of these reds will be a full-size LED you're accustomed to. One of these greens will be full-size. The other red and the other green will be what we call surface mount technology. And there's a bunch of videos that you all need to read, you all need to view over and over and over again in order to understand how to solder with surface mount technology. It is the smallest electronic component you will be soldering, and this is the very first time you will be soldering surface mount technology for most of you in our class. This is in preparation for next week's lab. This week's lab is a lot easier, a lot more parts. This has got more parts than you've ever built before in our class, but still, next week's lab is going to be more challenging because of surface mount technology. So when you have this picture, it is downloadable. I encourage you, unless you have multiple computer screens, if you're using multiple computer screens and you put this image on one screen and you put multi-sim on the other screen, okay? If you're not using multiple screens, then my recommendation is print this guy out. You have it on paper, and then while you have it on paper, then open up multi-sim and then start wiring things up, which I'm going to demonstrate in a moment. So before I go to multi-sim, are there any questions about this particular schematic? What's the purpose of R4 and R5? Think. I'll give you 30 seconds to think about the purpose of R4 and R5. Tick, tock, tick, tock, tick, tock.
It's to adjust for the amperage, I guess. LEDs tend to, or maybe voltage, right? LEDs function under a different voltage. Otherwise, they won't function correctly. Maybe.
Did everybody hear Edwin Sanchez's response? Was everybody able to hear that? Ivan, you were able to hear? Oscar, you were able to hear?
Yeah.
Okay.
Yes,
Does anybody have any comments? Or is he on the right track? He just threw something out there. Does anybody else have some comments?
I guess maybe you could control how frequently the LED flashes.
That's a good comment. Okay. Anybody else? Okay. Going back to when we started playing with LEDs. LED stands for what? Light emitting diode. Yes? It is not a light bulb, but it can burn out. And unless we have a resistor connected to an LED, that LED most certainly will likely burn out. So anytime you see an LED in a schematic, start looking for some kind of a resistor. And the purpose of the resistor is, and Edwin hit part of it, it is current limiting. Okay, everybody say current limiting. That is the function of the resistor for R4 and R5. They limit the amount of current to the LED so the LED doesn't burn out. We're not going to connect the LED directly up to the 5-volt rail with nothing attached to it. Otherwise, it could be easily damaged. And the same thing is true for R3 and R6. R3 and R6 are current limiting resistors for LEDs 2 and 4. So that's the primary reason for those resistors there. The resistors here, R1 and R2, they form a voltage divider. We have 5 volts on top, they form a voltage divider that supplies a very specific amount of voltage to this end of the chip. And then, oops.
It doesn't seem like you're coming through clearly.
Yeah, your audio's cutting off.
My audio's cutting off.
Oh, it's better now.
Is it better? Okay. So R1 and R2 form a voltage divider, and R2 and C1 form the timing circuit that allows for the pace of the LEDs to flash. Okay, so this is the schematic. Now let's go to, let's set this schematic aside. And go to the other file. The other downloaded file was an MS11 file. The MS11 file is a MultiSIM file. And MultiSIM will be opening shortly. Okay, there's MultiSIM. And the file you downloaded will open, and it'll have all the components. Get rid of that comment. Is it not responding? Okay, there we are. So this is very reduced from what you're accustomed to. So what I'm going to do is I'm going to zoom in. So view, zoom in, zoom in, zoom in. And in zooming, bring this over to here, bring this here. Quit moving on me. Why is this moving on me? This is a mystery.
Okay. I think
Okay.
you need to like click outside once because it was doing the same thing for me too.
Okay.
It's a little weird.
Let's go all the way up here and let's make this bigger. Hold on. Still want to zoom. View, zoom in. That's nice and big. All right. Yay. All right. That's nice and big. Fills your screen, yes? All right. So what we're going to do is we're going to go back and forth between this and, let me find my other file. Where did it go? It's behind my screen. Let's do this. Okay, so here's our schematic. So our schematic goes to show that the top of these resistors, schematic goes to show that the top of R4 and R5 have to be connected and have to be connected to the top of R1. And ultimately, all those wires at the top have to be connected to the positive side of the 5 volts. So we're going to go ahead and do that. So when your multi-SIM is open, you're given all the components. You don't have to place the components on. All you have to do is connect the wires. So don't try to do this now, but kind of watch what goes on with this. If you do happen to have multiple screens and you want to try it right now and you run into hiccups, that's okay. I can help you out. So I'm going to go ahead and connect the top of R1 to the top of R4 and 5. And the way I'm going to do it is I'm going to move my mouse pointer, which is an arrowhead right now, and place it at the top of R1. And the arrowhead changes from an arrowhead, the cursor changes from an arrowhead to a black dot with a crosshatch on it. I click, I pull a wire up, follow the grid mark, and I want to pull it up just a little ways, pause, unclick and click again, bring it all the way over to here, above R5, click and bring it down and click on R5. And now I've got a connection between R1 and R5, yes? I'm going to connect the wire between R4 to that rail. There it is. I'm going to connect these two resistors together. These two, the resistor and the LED together. Okay, that's good. And I'm going to connect from here. And I'll bring it up to here. Bring this over to here. Bring this up here and bring this over to here, make a connection. So the top of the circuit is connected with my 5 volts. Junction 1 will connect to here. Okay, so far so good. R1 and R2 are connected together. R2 and C1 are connected together. And let's see, I want to place this ground and move this a little lower, like to here, and connect the bottom of my circuit to here and to there. That wire, and connect this guy to here. You can do this in any sequence. I'm just doing the parts that I remember from the schematic. There's going to be other parts that I don't remember that I'm going to have to look at. Okay, and then I'm going to connect from here down to, it looks like this one will do. Will it make it? No, that ended in one point. So what I'm going to do is I'm going to select it, hit delete. It'll get rid of the wire. Give it a moment, build a new wire. And we'll just line up, I think it will here, bring it over and boom. Oops. Stop. There. Will it allow me to do it? It's going to be fussy. I guess I have to do it here. Okay. In any case, if you get a little zigzag in there, yeah, sometimes that's going to happen. All right, let me take a look at the previous diagram because the bottom of these LEDs have to hook up somewhere. So all right, so on my schematic, it looks like the bottom of these LEDs go to this pin, the output pin. So that's the second one from the top. The one at the top goes to the rail, and then these guys connect to the top of our 3 and 6. Okay, so with that being said, what I'm going to do is this guy will go here and connect to the rail. Done. And then these guys will connect here, up to here. Come here. And this guy will connect to here and move this guy over. And this guy will connect to here. And this guy will connect to here. So let's double check our schematic. Yeah, so the top of R3 and R6 are making with the bottom of the LED 1 and 3. And all of these wires go to the output pin, which is second from the top on the right hand of the 555 timer. The top pin of the 555 timer is tied to the positive rail. So that takes care of the upper part of the chip. Now let's take a look at the lower part of the chip. The lower part of the chip, I have two more pins. So the last pin here is a ground pin. And so this, I will come out and take it down to ground. That takes care of that guy. The bottom of these LEDs is connected to ground, and so it is also connected here. So I've got 3 pins on the right-hand side completely connected. Everything here is completely done. I can move on to this side of my schematic. And in looking at my schematic on this side, what I happen to have here is, okay, we have both capacitors going to the ground rail. So this capacitor will come down to the ground rail. This capacitor will also come to the ground rail. And I happen to have the top of C2 going to the top left-hand pin. So the top of C2 will go to the top left-hand pin, so that takes care of that. I have pin 3 on the right coming down and coming up and connecting up here. So I better have a connection between pin 2 to this wire between R2 and C1. So I can go right to here and there. So there's my connection between pin 2 on the left and this junction here between R2 and C1. Now what I'm going to need to do is bring a wire from this side, come out, come down, come over here, and bring it up here and connect to, no, that one's wrong. Beep, delete, double check. Comes down and connects to that wire between pin 2 and the voltage divider. So click, come here, click, come down, click, come over, click, and come up. I'm not liking how this wire's, I'm going to tie it to itself and get rid of it. And hit delete. I'm going to select it and delete. Down here, whatever, and up to there. Okay, so that one's done. So this pin 3 wraps around and connects to pin 2 right here. Pin 3 comes down and wraps around and connects to the wire that jumps to pin 2. Pin 3 of the chip comes up and goes to the junction between R1 and R2. So coming over here, pin 3 comes up and there. That completes that wire. So I've got the top pin, the second pin, the third pin covered. Now I just have the last pin on the chip on this side. And this looks like all it needs to do is just tie to the rail. Okay, so what we're going to do is connect to here. And connect to the rail. Okay, I'm taking a slightly different path from the schematic, but if you look at this wire from the 4th pin on the left, it comes out and it makes a connection to the positive rail of your voltage source. If you compare that to this wiring here, pin 4 on the left comes out underneath all of this and comes up and still makes a connection here. So even though visually I have an interesting little hiccup here, have an interesting little hiccup down here, have an interesting different route to get to my connection, everything looks like it's still connected. So I'm happy with all, wait, junctions, oops, let's bring the junction down. Okay, so now J1, J2, everything is ready. Cool. All right, so once it's all ready, we're going to put this in the run mode. And in the run mode, you have a little green triangle. You hit the green triangle, and the circuit goes into the run mode, which means that the battery's turned on and the LEDs flash. Which LEDs are on right now? These are green. Green is on. And in a moment, these guys will go off and the red ones will turn on. Give it a moment. It's a long moment. There. Did the green ones go off and did the red ones turn on? Okay, and then a long moment later, and it's another long moment, the red ones will go off and the green ones come on, yes? Okay, so the timer circuit is working, except it's boringly slow. So what I'm going to do is I'm going to come up here and hit stop. Stop. And once it's in the stop mode, I'm going to come down here and change the capacitor value for C1. C1 is presently 10 microfarads, and I said C1 is part of the timer circuit that controls the flash rate of the blinking. So if I double click this guy and change it from 10, take away the 0, oops, not the U, take away the 0, leave the U for micro, and go ahead and click in. Did the value change on my C1 from 10 microfarads down to 1 microfarads? Look right here. This was
Yes.
10 microfarads. It is now 1 microfarads. If I hit the go button now, the play button, run, they call it, the green arrow, boom, watch these guys flip back and forth. Red, green, red, green, red, green. Is this better? So what it is you're going to be turning in will be the actual MS files, okay? So I'm going to hit stop, and I'm going to zoom out just a little bit. Zoom out, okay? Because what I need to put in here, place a text box, and there will be a text box, and the text box will say, according to the directives, KO underscore FRANK. So your first name, your last name underscore, and it will be 555 underscore flasher underscore wiring underscore 14-20. And we're going to make this size 18. 18 is too big, sorry. Let's try 14. Yeah, 14 is big enough. Okay, cool. So you will have a title block on here on your schematic, and now do a file save as. So file, save as, and in whatever container you use, whichever you've created for your multisim files, I'm going to put this into our 50 class. I'll put in our 51 class. ES51. Cool. And this will be same file name. So KO underscore Frank underscore, and I've got the 555 underscore. That's not where I want it. Underscore flasher. And get rid of the rest of this. Underscore wiring underscore 4-14-20. So your file name will be saved last name underscore first name underscore 555 underscore flasher underscore wiring underscore whatever date you complete this exercise in. And I'm going to hit save. So it's saved with the same file name that I've created in this label down here. So first name underscore last name underscore 555 underscore flasher underscore wiring underscore today's date, or whatever date you finish this exercise. Doesn't take very long, but now it's saved, and it's got to be saved with the 1 microfarad capacitor. Yes, it starts with the 10, but you got to change it to 1, because if you turn this in, and I'm looking at your file, and these LEDs are not switching this fast, and you're forcing me to wait 8 seconds between switches, that's half score, people. Can you imagine if everybody turned in this document? I'm there going, waiting because you didn't change the capacitor to 1 microfarad. I'm waiting. 8 to 10 seconds later, finally, the LEDs finally flash. So that's insane. Is everybody clear what the assignment is in MultiSIM? Any questions
Yes.
on this assignment?
This is for week 3, right?
This was for week 3, yes. This is something we needed to have done for week 3, but I will extend the due date on this so that it'll be appropriate. You'll have up until what, Monday midnight of next week to get it done. So if there's still anybody in our class that's still challenged with getting MultiSIM working on their computers, with my PowerPoint that I sent out a couple days ago, plus this training here, which I'm going to post on YouTube separately of tonight's lecture. That should be plenty of time to get everybody in place. Edwin, you have a question?
Yeah, so I'm doing exactly what you did there. I tested it out. What's the purpose of J1 and J2 when it comes to MultiSIM?
Not with MultiSIM, but actually they turn out to be positions on the circuit board that we can connect for junction for outboard power. On the MultiSIM, it's a 5 volt. On your board, it will be to a power pack, battery pack. So that they represent. So right now, they're just placeholders that you're going to be using to hook up your battery pack, because you don't have a 5 volt battery pack. You have either 9 volt or a 1.5 volt cell pack. So it's either one of those combinations, whatever is required for this for next week to build. So J1 and J2 are simply placeholders in the schematic now. They serve no particular function for the thing to operate and for you to demonstrate that these LEDs are flashing correctly. Good question.
Okay, thank you.
You're very welcome. Very welcome. Any other questions regarding the MultiSIM?
That means I have a second chance to submit my work.
Well, yeah, because a regular, you're going to have to turn your mic, okay, because we're getting feedback. So a regular set of this with either green or red LED is not going to work. I actually need to see this thing working, flipping back and forth with a 1 microfarad C1 at this particular pace. So yeah, you do need to send me the actual MultiSIM file, and it's saved appropriately, and that's the one you're going to need to upload. Plus, I'm changing the point schedule on this. It was, what, 25 points? Yeah, it's going to be at least a 50, 60 point exercise for this particular one, okay? Okay, so we have up until next Monday night, midnight, to turn this in. Any questions on the MultiSIM?
Where did you go to get the text box again? I missed that part.
Oh, it's right here. You will place.
Oh, place, okay.
And in place, you will have text. And text, you will just bring this down here and boom.
Okay, thank you.
And you start typing, and here you can select the font, you can select the size, you can select other things that you want. And so you want to make sure it is the appropriate size, that it will in here nicely, so I can identify not only by the file name, but I can also identify by how you've labeled this, that this is in fact your particular schematic. Good question. Any other questions so far?
Just assume that you haven't graded any of these yet, because I already submitted one, but I haven't changed C1 to 1 microfarads and a header, so right? Okay.
Yes. Yeah. So yeah, if you'd be kind enough to do that, Ivan, then
I'll resubmit it.
Just do a resubmit, and then I'll look at the most recent date of the submittals, and we're good to go.
Cool.
Good job. Good job. Okay. Any other questions on this? Okay, let me do a final save and put this guy away. It is now put away, and go ahead and close this. This is also now put away. All right, bring this guy back over to here. Okay, let's see. My particular version of MultiSIM on my screen is version 13. Let me take us off the share and let's go to this view. Speaker view. Okay, so in speaker view, this is your version 14.2. I have this on another monitor. And in version 14.2, I've started some of the connections that we had done earlier. The reason why I show you 14.2, the default as it comes on, gives you a greater clarity of the different parts of the screen. So for example, if I move my mouse over to here, this pulls down an entire list of my various categories of components, all families, power sources, different things of that sort. I can also close this guy, bring down basic components. And so here's my basic components. So basic components would be composed of relays, sockets, capacitors, inductors. So as we go on to do more, you'll be selecting, whoops, you don't see what I'm talking about. Okay, how about here? All right, so when I pull down basic components, which was this one here, basic, place basic, and in place basic, I've got switch, transformer, relays, sockets, resistors, capacitors. If I go to resistor, if I go to capacitor, the symbol changes to a capacitor. It changes to a capacitor, and I've got all different kinds of preset values. I can pop those in. If I go to inductor, I can do inductor right there. If I go to resistor, resistors right there. So this gives you a little better view than the other screen that I had for the latest version of MultiSIM. The third pull down here is a diode, and I've got all different kinds of diodes that are here. Varactors, triacs, SCR, Schottkys, all different kinds of things here. This one's a Zener, and if I wanted to pull this over, I could. Then your tools for measuring are all over on this side. Let me get the camera over to here. Okay, and so your tools for measuring are all over on this side. So multimeter is here. So if I click this guy and put this in, boom, I've got a multimeter. If I click this guy, bring this guy over here. This is a function generator. I can generate waveforms. I got a watt meter. I've got an oscope. So boom, I can bring down an oscope. So we will do a separate lesson on MultiSIM in this resolution with better magnification, and you'll see it without the use of my desktop camera. Okay, but this one goes to show a much better and more clearer view of the pull down menu. So you have file, you have edit, pull down menu, you have a view pull down menu. There's a lot clearer place. So if we wanted to place our text, text comes down here. We can click this and we can place our text information. Okay. Okay. Our run is over here, pause and stop. So these buttons here are larger on this screen than on my 13.0 screen. Okay. Okay. All right. So I just wanted to take a moment and show that to you. Any questions on that? All right, now let's talk about the component parts that you're going to be playing with this week. And the component parts, let's go over to here. And oops, what happened? Okay, I'm going to go back to this camera and reposition the camera. So we can see these component parts. Let's see, I'm trying to figure out which view was correct. This is the bottom. This way. Okay. Okay, I'm going to go straight to the circuit board. The instructions are in Chinese, so don't bother trying to read the Chinese. It's documentation that's very, very poorly printed, but you won't be needing it. The one thing that you will need to pick up on will be CR 2032 lithium batteries. These are 3-volt batteries. So if the best place to pick up this type of battery would be at your dollar store, any friendly neighborhood dollar store or 99-cent store, they should have the CR32s, and they come in a 2 or 3 pack for $1. So very, very reasonable for these batteries. The battery, I have a coin battery here, and it will go into a holder. Now the holder happens to have a positive terminal, happens to have a negative terminal, and that's marked on your board as being positive and negative on the board. And how do you know to set it up? Well, there's a diagram here that shows a little white notch. And so that white notch is for this part of the battery holder, and it goes in with the black notch matching the notch up here. So that's the correct orientation for the battery holder. So you'll go ahead, pop that guy in, solder the pins over here. Notice something very interesting on this, that the negative pad is circular and the positive pad is what? It's shown as a square, okay? So I have a square for positive and a circle for negative. That becomes significant in other parts of the board as you're going to look at how to mount your LEDs. Anyway, so that's the battery pack. And then the battery here is slipped in only for you to be able to keep time on the timer circuit, okay? There happens to be, separate of this, there happens to be this component. This component is a screw terminal, and the screw terminal has your blade type screws right in here, and this is designed to go on this part of the board, like so. Now, when you go to solder this particular part onto the board, you have to make sure that the access for your wires are from the outside. You don't want to wire this butt backwards. I've had students do this. They've wired this wire connector here, and guess what? There's going to be a ginormous LED that's going to sit right here, a numeric LED. And if you wire it this way, won't it be incredibly awkward to get a wire into that terminal? That would be not so bueno, okay? So you want to make sure that this is set up so that the screw wire access is facing the outside. So this way your wires can come in without any obstruction from the outside, and then you tighten down the wires here and here. So your battery pack will have the positive attached to this terminal and the ground or the negative attached to this terminal. So the positive terminal was the one that's near the top of the board. And if you look at the back side, guess what? The traces show square for positive and round for negative. So whenever we have a component that has where the leads come up this way and one of them is square, what polarity connects to the square pad? It will be the positive one. Okay, so we've mentioned these two components, the battery and the wires for your power to be delivered to the board. The other noteworthy thing to be aware of will be this. Be very, very careful how you handle the LEDs, the LED displays. The LED displays, these wires are very, very fine wires, very easily bent, damaged, so be careful. You lose any parts or damage any parts, this kit will not work. All right, so they simply will go, they show the decimal symbol on the lower part of the display, and so your 7-segment displays have the decimal point right there and right there. So yeah, they're marked a little differently, but still that's where your decimal points are. So you have one LED that's supposed to display the hours, one to display the minutes, and one to display the seconds. So that's why you're given 3 sets of these 7-segment displays. Okay, so we'll go ahead and set those guys aside. That's discussed. Now, as before, when you're playing with a chip This is many pins, 20 pins. So when you're playing with a multi-pin chip, this is put into an anti-static block. You want to make sure before you go playing with touching this, you want to make sure that you yourself have not been moving around a lot, generating static electricity on your clothes. And when you sit down before you go to handle this, you should discharge any static electricity on your body onto any grounded part of your electrical system. So generally, if you touch the back of your computer system, the metal part of your computer system is grounded, so that will take off any static charges that are on your clothing or on your body. We're going to start with the socket. The socket, as you've seen before in previous exercises, has a notch on one side, no notch on the other side. That notch on one side of the socket has to fit on the board where there is demonstrated a notch. So this guy goes onto the board. Carefully line up all the pins, and the notch is characteristically on the left side of the board. All the pins stick up like so. You can see all the pins very nicely there, and do your soldering. Okay. The chip will be the last thing that you put in. Okay, the very last thing you put in will be the chip. So that guy will go in that way. Your resistors, you've got tons of resistors on this kit. You happen to have 4.7, 4.7, so you've got 6 4.7 kilo ohm resistors, and you also happen to have you've got 7 470 ohm resistors, and then you also have another 470 ohm resistor here, and you have another 470 somewhere else. 7 plus 1 is 8, so that's what you have. And then you happen to have a 10K ohm resistor and a 10K ohm resistor. So what I did was I marked these guys out. If you don't have an ohm meter to test these guys, you'll have to look at the resistor color bands. Let me do this. I apologize. Let me do. Okay, I think the focus is a little better on the surface of the table now. So 6 470s, 4.7 K ohms. Here's your 6 4.7 K ohms. Now I marked them 4.7, and you can double check the color coding. The color coding on this is coded as 4.7, so yellow, violet, black, brown, and then the tolerance band is brown. Which is a very low percentage, very high precision resistor. So these are precision resistors. They're excellent resistors. So again, the color coding is yellow, violet, black, brown, brown. And you should account for 6 of those. And when you account that you have 6, mark them 4.7 on the little masking tape and set them aside. Then you should have a pair of resistors. A pair of resistors are taped separately, and their color coding should be brown, black, black, red, brown. And so brown is 1, black is 0, another black is 0, so that's 1 followed by 2 zeros. And then the multiplier band is red. Red is what? Another 2. So you have 1 followed by 4 zeros. What's 1 followed by 4 zeros? 10,000. So these are your 10K resistors. How do you read the color code? Write down 10K and set those aside. And then you want to identify that you have 8 of the 470 ohm resistors. The 470 ohm resistors are identified as yellow, violet, black, black, and brown. Okay. So yellow is 4, violet is 7, black is a 0, so it's 470. That next black happens to be a multiplier, and 0 means we're not going to multiply by, we're going to multiply by 10 exponent 0, which is a 1. So 470 times 1 gives you 470 ohms. Brown is the tolerance for this particular resistor. So you want to make sure you've got 8 of those. Do not mix these resistors up. If you have the wrong value in the wrong place, you're going to be very, very sorry. So my recommendation is start with your 470 ohm resistors. You got 8 of them there. 7 of them go here. 1 of them goes here. So if you get all of those guys here, and here first. Boom, you've eliminated primary source of confusion. Then you happen to have 6 of the 4.7Ks, and these go right here. So that'll be your next set. Get that done, and they are done. Then you have your 10K ohm resistors, your 10K here, and your 10K here, and those guys are done. That takes care of all your resistors. Then you happen to have some diodes, these diodes, very small. They are, yes, it looks like glass, it is glass. These are glass encapsulated 1N40, 148 diodes. And these diodes, you can tell, are polarized. There's a black band that's characteristic on one side of these components. This is a polarized component. You wire this in backwards, this circuit will not work. So where do these diodes go, the 4148s? So the 4148 is identified here, and identified here. So 1, 2, 3. So diodes number 5, 6, and so D6, D5, and D7 are marked on the board 4148s. And you can tell also which side of D5 is supposed to be the cathode. The cathode is the black banded N, the negative side of the diode. It happens to be on the right-hand side. So if I'm going to use this diode, I have to turn this guy around, like so. So the black band is lined up with with this band on the 4148 symbol on my board. Any questions on how to line up your 4148 diodes to go into D5, D6, and D7 positions? Any questions on that? So far, so good. Okay, moving on. As we move on, here we go. Next components of interest. These guys all look the same. They are very, very special. There happens to be 1, 2, 3, 4, 5, 6. There's 7 of these guys. 6 of them are the same, and 1 is different. So the 6 that are the same are a transistor, and it's a transistor marked here, Q1, Q2, 3, 4, 5, and 6. These happen to be 8550 transistors, and 6 of these are 8550s. You can tell what they are by looking at the flat spot of the transistor. Hold it up to light at a certain angle, and you'll be able to see the part number very clearly printed on the face of these guys. So these guys, these 6 over here on my right, happen to be 8550 transistors. This single guy over here does not have that same marking. The single guy here doesn't go in Q1, 2, 3, 4, 5, 6. There's a separate function over here, and it's marked U. U means I have a microprocessor. U is a microprocessor. So U1 is a very special microprocessor. It's listed as 78L05. That's this guy here. A 78L05 is a 5-volt regulator. And that 5-volt regulator goes for U1. And again, its markings will be very clear to you once you hold this up to the light a certain way. The lettering will be shouting at you, 7805. Okay. And as before, if we look at the board, the one middle lead goes backwards, the one on the left and the one on the right are splayed apart slightly, and this particular guy will go into the board like so. And you push it down. It doesn't have to go very far down on the board. I don't recommend it to go too far down on the board because you have other things that stick up off the board. So this particular power connector is going to stick that high up off the board. So if you make your transistors the same elevation off the board as your power connector, you're doing fine. A lot of students have taken these transistors and pushed them all the way down. I don't recommend that for several reasons, because especially for a 7805, this is a 5-volt regulator. If you're putting on this soldering, on this pin, these pins back here, putting heat on these pins to solder to them onto the pads, that heat rising up that wire can go up into the chip and destroy the internal components of that chip. On these guys, it will be transistors. On this guy will be many transistors and other components. This is a microprocessor, the 7805. That's why it's identified on board with the letter U instead of transistors with the letter Q, 1, 2, 3, 4, 5, 6. Okay, so any questions about the spacing that I highly recommend for the transistors to be off the board? Okay, I'll pull this guy off. All right, so that guy is your 5-volt regulator, and you've got 6 transistors right there. Cool. Okay, coming right along. Next is your crystal. This is for 12 kilohertz, something like that. The crystal, 12 megahertz, sorry. So this guy will go onto the board here where it says T1, because T stands for timer. And it'll go right down in there. And if we hold it up to the light just right, yes, you can make out 12.000 in the lettering. So keep that upright. The crystal is non-polarized, so it doesn't matter. If you look at the traces on the back, neither one of these is square. They're both circular, so it doesn't matter. But you know, for the board to look nice, since it's printed with this being the top, this being the bottom, it'd be nice if your crystal was right side up instead of upside down, okay? Any questions regarding your crystal? I'm gonna pull this guy off the board.
I got just a quick one. So that one we could put all the way down, right? Like
this one, yeah, this one goes all the way down.
Okay.
Yeah, there's just a crystal on the inside. This is almost indestructible as far as a soldering iron goes. So there actually is a quartz crystal in here. When we hit it with a charge, it'll start to oscillate, and we use that charge on the quartz crystal for timing. So this is in essence, for many digital watches, the quartz crystal in digital watches. So when your watches say quartz of some sort, they're using a quartz crystal very similar to this to establish the timing on your wristwatch, those of you who still wear wristwatches. Okay, okay. Any other questions regarding the crystal? That was a good question. Okay, moving right along. There happens to be 3 capacitors. These 3 capacitors are the same value. They happen to be electrolytic. So electrolytic means they're polarized, yes, which means there happens to be a short lead and a long lead. It's negative to be short, it's positive to be long. The negative lead is also identified by a white stripe on the side of the capacitor, and that white stripe goes to show a nice bar showing the negative symbol, that lead attached to that side is in fact negative. So these capacitors will go here for C2, C3, and C7. C2, 3, and 7, these are your electrolytics. They're marked 10 microfarad, 10 microfarad, sorry, like it's 10 microfarads, 10 microfarads, and 10 microfarads. The shaded part of the circle is intended to be negative. So when I go to put any of these capacitors on, and I'm going to go put C2 on, so the shaded part is negative, the long lead is negative, so I'm going to put the long lead on the shaded part of the circle. Start that guy first, since it'll fit in first. And then the short lead is positive, and I'll bring that to the positive part of the circle. Drop that in there, and that can go all the way down.
I thought the short lead. Yeah, I thought the short lead was negative, and
Yeah,
the
same.
long is.
Oh, sorry, I did that backwards. Yes, thank you. It's been a long day. So negative to be short, positive to be long, like so. It'll go down onto the board, and these can go all the way down to the board this way. And if you look at it again on the back side, what's interesting, did they do that here? Oh, they didn't do the square pad on this one. That's interesting. They did the square pad on the LEDs, but they didn't do the square pads on the electrolytic capacitors. Very interesting. Okay, thank you. Then you have a big capacitor. Where's that big guy? There's one larger capacitor. And that larger capacitor is a 220 microfarad capacitor, and that will go here where it says C1. So 220 microfarads will go there, and life is good when you go to find yours. Mine's sitting on my desk behind some stuff. All right, next you happen to have 4 red LEDs. Okay, now LEDs, as you know, are in fact polarized. So positive to be long, negative to be short. And the board is also polarized. So it goes to show positive and negative for D, for that diode. Diodes go, they can go on the board. And if we look at this very carefully, they did mark this on the pad. So right here, if I hold this up, you can see, yes, this pad with the longer lead, which is positive, is square. This pad for the shorter lead, which is negative, is circular. So be sure to be mindful of the polarity on the LED so that they don't get reversed. So that takes care of the 4 LEDs. And the 4 LEDs are 1, 2, 3, 4. That's where the 4 LEDs go. Okay. Then you have ceramic capacitors. You have these little ceramic capacitors, and then you have another ceramic capacitor over here that's a little different in size. So the 2 little guys are marked with a 30, and the 2 little guys are going to go on your board as 30 picofarads, 30 picofarads here and 30 picofarads here. They are non-polarized. It doesn't matter which wire of the capacitor goes into which hole, but you have a pair of those capacitors going here and here, okay? The remaining ceramic capacitor is going to go on C4. C4 is this guy, this rectangle over here marked 104. And this guy will have a marking on its face that will say very faintly, and it does 104. So this capacitor will go here where it says 104. Any questions about your 2 30 picofarad and your 104 capacitor going where they go? All right, the last thing to talk about is the switch. Here is the switch, and the switch is going to be placed right here and here, and the switch will go there and there. So how will it go? Do not wire this 90 degrees out of phase. So what I mean to say is this switch has the pins coming off of the right side, and it has pins coming off of the left side, okay? Pins there and pins over here. Do not wire this guy up this way where the pins are at the top and the pins are at the bottom. That will not cause the switch to work properly. So those pins have to be on the left side and the right side as you put the switch onto the board. Now this you're going to have to give a little bit of encouragement in order to get the wires of the switch through the board. So just gently press, gently press, gently press, and you can see the wires poke through like so, and the switch is flush onto the board like so. Yes, okay. That just by gently pressing, but you want to make sure before you gently press that in place that the wires for the switch come off the right side and the wires for the switch come off the left side. So what will happen here, just to prove things to you, if I go to hook this up with a digital multimeter for testing for continuity, to continuity, okay, here, and I go to test my leads. So in the continuity test mode, I go to test my leads. It beeps, yes. So that means I've got continuity on these 2 pins. If I go to this switch, and I'm not sure if I have enough on here to grab, but maybe if I get lucky. Okay, 1 there and 1 there. Is that enough to grab? Maybe if I put my hooky guy this way. Ooh. And I go to press the switch. No press, no continuity. Press, continuity. That's the way it should be. It will give me continuity between the thin trace and the large trace on the board. It'll give me a continuity between these two pins down to these two pins as long as your orientation is correct. So any questions about how that switch is supposed to go on the board? That'd be the only tricky thing is if you push that in 90 degrees rotated, this thing will not work properly. Guy there, this guy here, okay, and this guy here. Cool. All right. Any overall questions concerning the project kit? All right. Now let's go ahead and take a look at
It looks like in addition to that, the components, there's some jump wires also in that one, a couple of them.
let's see, were there jumper wires that were included in this? I don't recall seeing any jumper wires.
No, but the diagram shows maybe a little Q next to Q5 and Q2. Maybe we got to jump to a little section of jumping wire or whatever.
Let's take a look here between, are you talking about the schematic here? This diagram?
On the board.
Oh. On the board, yes.
Q5
Okay,
next to it.
you,
Yeah, right
oh,
there.
yes. You have some short wires that go here.
And then next to Q2.
Yes. So you have a jumper wire here, this white wire, this line, and this white line. And what you do for the jumper wires, my friends, thank you. What you do for the jumper wires will be the leftover lead from these diodes. You see these leads or any of your resistor leads. You happen to have some nice wires there. These wires will go onto the board from here to here. So when you put your diode on the board, and go ahead and get one of these diodes on the board here for you. So let's go ahead and bend this guy here and bend this guy here. Much nicer if I did it with pliers, but I'll just do this real quick. This diode will go here, and this diode will go here. So you see how much wire we have left over? So you'll be using these wires after you solder and snip them in place. You have plenty of these wires left over between all the resistors and the diodes that you're going to be putting onto the board for the jumper wires here and here. Thank you, Edwin. So everybody remember, you got a jumper wire here and a jumper wire here. Good. Any other questions? That was a good catch. Thank you, Edwin. All right. Now let's take a look at what else you're going to need. And what else you're going to need is on week 4. Let me grab the right mouse for the right computer. Maker case. So on the maker case, and download this guy and download this guy.
One more thing, Mr. Coe.
Yes.
The LEDs for the numbers.
Yes.
The orientation of those. I suppose the dots is going to be towards the bottom.
The dots are going to be towards the bottom. Yes.
Yeah.
They happen to be printed in on the instead of both on the right, they're both printed both on the left.
Okay.
The dots will go on the bottom.
All right. Thank you.
Yeah, sure. As I'm looking at dice maker case design, good. We're going to need for you all, let's go to share this screen. Share screen. Share. And share. Okay. So in week 4, so if I go home, you can see what the week looks like. So 4, right? Week 1, 2, 3. And go to week 4. maker case. This is a project that you're going to be doing on your computers, and then you have to send a file to Nabil, and Nabil will then laser cut this in at school. And what this guy entails is the software. So let me go ahead and show you this. There is a logo. So here's a logo. It's presented as a TIF file. So you can use the logo and embed that into any part of your case.
You can't
So
see
here,
the logo right now. It's not on
I
the
took
screen.
it off the screen. It's right here. Here's the logo. Here, let me minimize this. Okay. On the share screen, can you see the logo?
Yes.
All right. So that is a logo that you put on one of 5 different surfaces. You have 5 surfaces that you can play with on this maker case, and that you can actually put some designs and some imprints on. It's really, really cool. So what you do here, enable editing, and what you do is you go to, you need Visio. So let's see, Nabil will be on at 7:30 with my other group, and we'll bring up to date if he has found a better resource for Visio. Victor, you found Visio on your own, and you downloaded and you paid for it. Yes, Victor? Paid for it. Yes, Victor. Yeah. How much did it cost? How much did it cost?
$60 per year.
$60 for the year. Okay, so you're going to be using Visio for more than one thing. But I'm hoping that you won't have to pay $60, that all of you won't have to pay $60. But let's see what Nabil is able to come up with. Anyway, that's one of the assignments that I gave to him to do some research on. What you're doing here, though, my friends, is following the instructions on this Word document, the LAB4 Word document, and you will be designing using the software, the maker case software, all of the appropriate dimensioning, the hole positions, the size of the cuts, all the dimensions and everything are given as here as part of your Word document. If you follow these numbers to the letter, this is a 0.05. It's not a 5.0. This is a 0.04. It's not a 0.40. You have to look at these very carefully and make sure that whatever specifications are given to you here, you don't change anything of the specs. Otherwise, the 5 pieces, well, actually 6 pieces because there's a cover as well. The 6 pieces that go to make your box will not fit with each other. These will be laser cut on our 1/8" plywood at school. But what's interesting about this is in years past, what students have enjoyed on the front, on the right, on the left, the back, and the bottom is they've put the logo on just left or right side, but you still have 4 other sides that you can put on your own design. And I've had students put on some really interesting designs. They put their name and Old English type. They put on a picture of something that's on the side. And as long as the picture has got good contrast, like this logo has really good contrast, it's just black and white. So what'll happen is any part that's black will be laser cut into the plywood a certain depth, and any part that's white will be left raised on the surface of your plywood. And so this image will be basically etched into the plywood surface of your box using a laser. So it doesn't cut all the way through, but it etches into the surface a fraction of a millimeter, just so that you can see this pattern when you are holding your box, which is really, really cool. So moving this guy out of the way and following this is, you follow this through, and the software will tell you, yes, you make this whole, these dimensions, you follow, 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 follow. And where it says how you're supposed to save this, you're supposed to make sure that you select SVG, so scalable vector graphics is a .svg file, has to be saved a very special way so that those files will be what you're going to be sending to Nabil, and Nabil will use those files, your own files, to connect to the laser cutter in order for you to have your box cut, because the last project that you're going to put into this box will be your week 8 project, which will be the electronic dice project. Okay, so what you see here on figure 8, this is the side panel. This is just one panel. So you have a logo here and you put down electronic systems technology. So what are you going to do with the other 4 surfaces? You can't put any design on the top because your circuit board faces the top, but you have the left, the right, the front, the back, and then you also have the bottom. The bottom is your biggest surface. And so think about between now and when you turn this in, what kind of design you'd like to put on there. And what might be helpful is this. Let me take a look and see if I happen to have, I think I do. Let's go here, let's go here, let's go here, and under student submittals. And let's take a look. APC MultiSIM, maker case. Somebody had an interesting maker case. A lot of these are. Let's take a look and see. No, I don't happen to have that, so I can't demonstrate it for you. Oh, maybe. Truly, that's all he did. Who did something interesting? I know somebody did something really interesting. How about this one here? Okay. All right, so here's an example of a student who had followed all the steps and didn't do anything more than put his name on the front and put a logo on the side and put the class. And when he did this, the top, all of these will be laser cut out. These 4 holes here will be for you to screw your circuit board onto the top. You've got a whole bottom surface here to put some kind of a logo or some kind of an illustration. Another long surface here. So you have 1, 2, 3, 4, 5 surfaces to think about customizing your particular project, okay? So we are looking at this using the Visio software right now, but the file that Nabil needs is the .svg file. He doesn't need the Visio file. You're going to turn in the Visio file, so I have something to grade, but the SVG file that you save will be what is turned into Nabil for him to load up onto the computer. And let's see, case plans. See if Hallett did anything interesting. No, not very creative. I guess the next group after them went hog wild and did all kinds of stuff, and I didn't save those particular files, but I leave it to you for your creativity. Whatever image you want to put on here and pour it in, try not to use anything that has color. Try to use something that is only black and white, because the laser will cut black and white very, very well for you and give you a very nice image. If you paste something in here that's in color, yes, it's pretty for you and I to look at, but the laser won't know what depth to make the different colors. So do not put in a photo, for example, okay? Because that just simply does not laser cut very well. So any questions about that particular part of the project for week 4 LED dice maker case? Any questions here so far? Okay, and let me go home. Let's see what else is scheduled for week 4. Okay, metal bending, we won't, oh no, skip week 3. We won't be doing any metal bending. Sheet metal introduction, no, we won't be doing anything with sheet metal. Maker case drawing upload, that's where you're gonna upload the drawing. And in-class participation, active summary, no, that basically is that you got the soldering project, you've got the multi-sim to do, and then on top of the multi-sim, I'll give you a slightly more advanced multi-sim with a transistor amplifier. I'm going to have you do a transistor amplifier in multi-sim with a signal generator and an oscope. It'll be your first amplifier design. It will know, oh, here was my big capacitor. I was looking for that big capacitor. All right, cool. So any questions about the soldering project? Any questions about the multi-sim that you're going to be wiring up? Any questions about the maker case design?
I have one on the maker case design.
Yes.
Are we going to have another software, or are we going to do it with the Visio?
You're going to do this with, let's here, get this guy out. So you're going to go to makercase.com. So copy and pull this guy down and go here. So this is makercase.com, and with makercase, you're going to build a basic box. And then here's where you see all the dimensioning information for your box that was shown in the Word document here. Okay, so it is maker case, easy laser cut case design, case dimensions. So what we happen to see here, and let me magnify this a little bit more on that column. Okay, so on the case, does it have box? The scale is in inches, box width is 3.5, box height is 1, box depth is 2.5. So I have over here in maker case, inch versus millimeter. So I select inch, and then this guy will be 3.5. The height will be 1. Depth is 2.5. And you see how things are changing in the background. So now do we happen to have a box? Oh, I've got to talk about the thickness too. Material thickness, 2 layers for box dimensions, maximum thickness. Okay, where's my thickness? Yeah. Oh, no, it isn't. Because, let's double check this. Yeah, 3.5, 1, 2.5. Are these inside or outside dimensions? They are outside dimensions. Material thickness is 1/8 of an inch, which is fine. And then the joints will be finger jointed, which will be finger jointed. Will this be a closed? Does it ask for closed or open? It doesn't ask for closed or open. Huh. And it is 1 inch. Okay, so we're doing all of this in maker case, which you can do on their site. And I'm just going to X this out. I'll ask Nabil about this, but we've done for years these boxes using these dimensions, and it's worked out just fine for the type of width that we have. So this part here is not in Visio. This is done on the maker case site. Did that answer your question? Okay, good question. And I just pop these, and then so now you have something that looks, guess what? Isn't it remarkably close to this image that we have here? Don't these two jive? And then in a little while, you're going to get into dimensioning the fingering, exactly how these are going to cut in. So if you look at this drawing here, because we haven't gotten to that part of the scaling yet, it just shows 2 tabs from the top and it shows 3 tabs from the side. Well, here it shows many tabs from the top and many tabs from the side. So these are further dimensionings later on in the worksheet. So I'm not doing the whole thing for you, but I wanted to show you, yes, we're going to do this in Maker Case, and it's already starting to take shape of what your final box will look like. Okay, good question. All right, so you have this to do, so follow the directions on the Word document, and where it says you're going to save this in SVG, and then where you're going to save this as a Visio file, the most important thing is the SVG file once you get your images on here. So yes, you put your name on the side, put your logo and ESYS 51 Chabot College on this side, and you now have the whole back side and the other left side and the bottom that you can put in some kind of an image, and I highly encourage you to do so since it's going to be cut and customized just for you. Yay. Good project. And there will be a separate homework assignment or two on MultiSIM that I'm going to be doing a tutorial on and then giving you an assignment on. So I'll do that tutorial in, and I'll put it on YouTube. So those of you who have looked at the YouTube videos under Co-Guy, you'll know what I'm talking about. Who has not seen the Co-Guy videos?
I haven't.
I have not.
Mm-hmm. Okay, well, some of you may not have to, but certainly Oscar, yeah, you're going to need to connect with me on that. Okay, so any other questions? I think we're almost out of time, but I think you've got a pretty good head start on everything. So the only thing you're going to need to get is that button battery. And let's go to here and go to here. And let me take a quick picture of the screen. So those of you who have the cameras, make sure your cameras are on now. And I'll take a picture for roll call. And, oh, my smiling face. Let me put, wait, get me on there. There's my smiling face. Yay. All right. So we'll do this, magnify and hold the camera. All right, smile. Okay, got it, you guys. That's great. All right, so with that, good session. As other questions arise, don't hesitate to hit me up. Oscar, we need the chat, but I've got another group coming on at 7:30, which I have to click to. I will send you the link on it, or you have time to chat with me later tonight?
Yes.
Okay, so why don't we do this? Let me have your cell, and I'll give you my cell.
Yeah. My cell is 209
209
850
850
5238.
5238.
Correct.
Okay, 5238. Okay, mine's 415 279 6488. And so I'll text you before I call, but the other session starts at 7:30 and will run till, I don't think it'll run that long. It's scheduled to run till 9, but I don't think it'll run that long. It'll probably be half hour, 40 minutes at the most. But I'll text you first and see if it's convenient, and then we'll chat again, okay? And we'll get you cooked up. All right, Oscar, thank you so much. We'll talk to you later. Guys, fantastic. Thank you very much for a session. And any questions that arise, definitely give me a call, okay? Okay, guys, have a great evening. Take care. Bye-bye now.
Bye.
Thank you. Thank you. Thank you.